Hello, welcome to RC Video Reviews. Today we're going to spend a little time on Rotorflight, and we're going to probably cover one of the most important things that you'll need to be able to do on the Rotorflight fly barless system of your choice, and that's the geometry. So we're going to cover geometry, and we're going to actually do a full head and tail geometry setup on the helicopter that I have on the desk. This is an SAB Goblin Buddy. It's a 380 class helicopter, and we're going to do a full setup. And I picked a 380 because it's easier to manage on the desk. I also want to, before we get started, I want to do two things. Number one, I want to thank Radiomaster for sending the Nexus out to me for review. And I'll remind you that if you'd like to pick one of these up, there's a link in the description. It's an affiliate link. And keep in mind, if you use my affiliate links, the channel gets a little bit of a commission, but that's paid by Radiomaster, and it costs you nothing extra. The other thing I want to do is welcome Rob Burrow to the session tonight. And Rob is a OMP team pilot, and I've seen him fly. I've seen his flight videos, and I've spent a lot of time working with Rob on different setups, and we spend a lot of time together on Discord. Rob's an expert pilot. So Rob, thanks for joining us, and I appreciate you offering your experience on Rotorflight for this setup video.
Yeah, of course. Glad to help.
Good. Okay, with that, let's just jump right into it. I want to start out by explaining that when we started this series, I thought initially we would get away with 3 videos, but the reality is there's no way we can do this in 3 videos. It'll just be too long. So we're going to do 2 more videos. There's going to be a video 4 and 5. The video 3, that's the one we're on now, that's going to be for the geometry only, the head and tail. We're going to really focus on the mechanical aspects of the setup. And then the next video, video 4, will be on the motor, ESC, and telemetry, including your governor setup. So we'll focus on that on video 4, and then video 5 will be the PIDs and the remainder of the configuration that you need. So we decided 2 more videos would really be appropriate. So look for parts 4 and 5 in this series on the Nexus. So with that said, I'm going to go ahead and we're going to talk about wiring first, because let's talk about the helicopter first. Before you get into the geometry, we're going to make a few assumptions. The assumptions are that you've built your helicopter according to the plans in your book, and it is ready for your linkages and your geometry setup. Okay, let's assume that. And then the second thing is that you've installed the Nexus on the helicopter. So you can see I am using the RP3-H receiver, and that's tucked down there on the bottom. And then here we have our servo connections into the helicopter. So Rob's going to walk you through what all these connectors are, and then after that we'll get into Rotorflight and start doing the geometry work. So Rob, take her away.
Servo swash like this. Servo 1's always going to be the pitch servo, the elevator servo, which is typically in the front or the rear. 2 is always going to be the left side. That's and here. 3 is always going to be the right side.
And that's here in this case.
The left control. Okay. Yeah.
And
then tail is tail.
Right.
ESC is your ESC.
That's your signal wire
RPM.
to the ESC. Yeah.
Right. Yeah. And RPM is the RPM signal from the ESC, which you really want with Rotorflight.
Yep.
And then in our case, we're using S-Bus as an input for ESC telemetry.
Okay. And then the signal wires are the top pins. So make sure for your RPM signal and your S-Bus signal, you're using the top pin. Okay. All right. So there we go. That's that. Now we'll go back to the desktop. We've got Rotorflight open. I've got it connected to the helicopter. And we'll go ahead, before we connect anything, any battery, let's go ahead and talk about what we're going to do on the Rotorflight tabs, Rob.
Right. So with a fresh setup, you want to make sure your ball links are popped off the servo arms.
All right.
I forgot to mention that last time.
So let's
make sure those are off for this part.
Let's just show what we're talking about here. So the ball links on the servo arms, these go to the Swashplate. So I've disconnected them. The Swashplate side is still connected, but all the way around, I've disconnected the ball links from the servos. So the servos are all standalone, all by themselves, nothing connected. And the same thing on this side. All right.
And yeah, and you don't want to power the servos yet, so keep the battery unplugged.
Hey, wait, we need to disconnect the rudder too, right?
Oh, right.
Yeah, so we want to disconnect all of the control surfaces. So let me swing back here and I'll disconnect the rudder as well. Okay, the rudder is disconnected as well. So all of them are cut or released. Okay, now what's next, Rob?
So let's go ahead and go into the mixer tab, which you're already in. And the first thing you want to do is your cyclic calibration and yaw calibration. You want to drop those down to 70% and 30%. And that's just to make sure that we don't overdrive it when we first power everything up.
Okay. So cyclic calibration 70 and then yaw calibration 30.
Yep. That way they're not going to travel too far. And
now
then we can go ahead and move on to the servo tab.
One quick thing, guys, because I've already been in here tinkering, your default values may look different than this. Don't worry about that too much. You know, to start with your defaults. We'll cover the other numbers later, but the main thing is make sure you set your cyclic right here to 70 and your yaw to 30. Okay. Go ahead, Rob.
All right. And then now we can go ahead and move on to servos.
Okay. So we'll click on the servo tab.
So in this case, it's already set up. The main thing is servo number 4 because it's a yaw servo. Those operate on a narrow band, which a lot of people call 760 microsecond or 760 US. So as you can see, we already cut the numbers in half all the way across.
So the cut in half is a reference to the number above. So where I have negative 350, that's half of the min, and 350 is also half of the max, and then 250 for the scale is half of the one above. So that's what we mean by cut in half. That's the reference.
Yeah, and if you're running 760 microsecond on your cyclic, you'd have to go through servos 1, 2, and 3 and do that there as well.
Right.
But we're not here, so that's okay.
Right. Okay. And then also for centering, you're going to have a different value here. We're going to cover this in just a moment. But again, your values to start may look a little different than mine, but don't worry. We'll get to why they're changed in a few moments.
Right.
Okay.
And then at this point, we can, once you've done all that, you can go ahead and power it on.
Okay. So all I did is connect the battery to the ESC. All right. We're powered up.
Yep. And let's see. And then from there, this is where you want to make sure all your servo arms are installed as close to perpendicular as possible, or in the whatever alignment the manual tells you.
Well, should we turn on the override first?
Oh yeah.
So turn
with
that
override on.
Yeah. So the reason we got to do that is because I'm sitting here, you know, Rob's talking about that, and I'm looking at it. My radio is controlling the servos right now. So the reason you want to do servo override is because that tells them to go to the center, right? So that centers up the servos. Now what we're going to do,
no influence.
Yeah, that's right. No influence from the radio. Now what we're trying to do is we're going to use the center option over on Rotorflight to get these arms to be it's perpendicular to the main shaft is what we're after, right, Rob?
Generally, yeah.
Yeah. Okay. So that's what I'm looking for is a 90 degree between the servo arm and the main shaft. And to get that, we're going to go, okay, remember the elevator, this is the pitch, this forward one is the pitch on mine, and that's number 1, right? So we're going to go, we're going to go look at number 1, and I'm going to show you a quick little tip that Rob showed me. If you click in the center field for number 1 and then use the arrow keys on your keyboard, when you make movements, the movement occurs on the servo at that moment in time. So you can see, hopefully, that servo moving up. You see how that number 1 servo is moving up? That's not what we want. We want to make that perpendicular to the main shaft. So I'm just going to hold the key, the up key now, until I see perpendicular to the main shaft, and we'll let that go. Now, some of you guys may say, John, that's not exactly right. You have to understand, doing a video like this, I can't stick my face over the top to look, because then you won't be able to see. So it may not be exactly perfect, but you get the idea. Okay, what we're looking for here is 90 degrees. We want this to be 90 degrees to the main shaft. That's what we're looking for. And you're going to do that for all 3 arms. So this was number 1, and then we have number 2, and this will be number 3. So all 3 arms, you have to do the same thing. Okay? All right. So that's that. I'm going to do one. I'm going to just eyeball it myself real quick and get these as close as I can really fast. I'll just check the other side as well. But again, guys, I've already done this. So this one is number 3. Oops. No, it isn't. This number 2.
And the same thing for the yaw servo.
Yep, same thing for the yaw servo. That's right. And the yaw servo
Like
on the buddy is a little bit different. We'll talk about that.
Yeah. Yeah, this is one of the ones where you want to see what the manufacturer recommends, but generally it's going to be parallel to the main shaft.
Okay. So in this case, on the buddy, you'll notice that the yaw servo is not 90 degrees to the case of the servo. So let me use my pencil to illustrate the point. In fact, I'm going to switch over to the big camera too, because that'll make it a little easier to see. Okay. So on the big camera, you can see that that arm is not at 90 degrees to the case. It is definitely at an angle, but it is perpendicular to the main shaft, and that's what we're looking for here. And the reason for that has to do with geometry. You don't want a different distance traveled on one end of the servo movement than the other. That's why we're looking for this perpendicular to the main shaft. Okay. Okay. So we'll go ahead and stipulate, guys, that at this point, I've verified that all of my servo arms are at 90 degrees. That's the key, or 90 degrees to the main shaft. So we'll stipulate that that's accomplished. Whether or not I have it exactly right, I'll worry about that after the video's over. We just want to say that's the step that you're supposed to take now. All right,
that's
Rob.
How you do it.
Yeah, there you go. So
all right, so the next thing is we need to check the direction. Okay. So with the servo override, just pick like servo 1, go to positive 20.
Okay.
And that should cause the that should push the swash up.
Okay. And it did. So this is my pitch servo, and when I went to positive 20, that arm definitely moved up. In fact, I can make that easier to see. So that's the servo we're looking for. So the bottom line is any positive value here, you want to see a movement up. So there's up on the pitch servo, and then here is number 2, which will be the left side, and hopefully you guys can see that one's right here. So that's the port side, and so that's back to level. And then we'll do the right side. We'll go positive, and that one goes up as well. So that one is right here. That might be a little harder for you guys to see. So there we go. All we're doing is verifying direction. And if one of these were wrong, Rob, how do we fix that?
Got the little reverse switch up there.
Right up there. Here. Right. So if you move to a positive value and the servo goes down, you reverse it right up here. And in my case, you can see all 3 of these are reversed, with the exception of the tail rotor. Okay. Since I think we're good there, I'm going to just hit save to save my progress so far. And now what's next?
Yeah. So we didn't cover this last time, but so the next thing that we should do is to make sure that the servo arms don't run into anything. Mm-hmm. So you could pick servo 1 and then just override it. Just kind of work your way all the way to the end and just make sure the servo arm doesn't physically run into something.
Okay.
Like the body or itself or the mount or something like that.
So I'm going to switch to the big camera, and I'll use the slider to make the servo move so you guys can see what's happening. But we're looking for any kind of mechanical binding or touches on the airframe, and right there I think we're still clear.
Yeah, that's fine.
So that looks pretty good, and that's as far as it goes. That's all the way up at 80. I'm not getting any movement past 80.
And then check the other direction.
So we'll go down to 40, and
yeah,
it looks
all right.
Yeah, it looks clear. There's a wire there. I know I can see in the video that it looks close, but it's not. So that's negative 60. Here's negative 80, and we're clear. So that looks good to me.
Yeah. So if you had a situation where that arm was running into something, like say the frame or a bracket or something, you would go through and reduce your min or max to stop that from happening for that servo.
So here's what he's talking about right here. That's kind of like your outputs. So you'd reduce that number if you had contact.
Yeah. And that'll make sure the servo never, ever goes beyond that point under any circumstance.
And you don't want, that's bad. You definitely do not want that to happen. So
exactly. Yeah.
Okay. So, and you'll repeat that process for all 3 servos. Don't cheap out on that.
Yeah, all 4.
Oh, sorry.
Even
all
yaw.
4. Yeah. Yaw 2. That's right. Okay. All 4. Okay. All right. Very good. What's up next, Rob?
All right. So at this point, you can go ahead and put everything, all your overrides back to 0, and the ball links can go back on.
Overrides back to 0. Okay, they're all at 0. And go ahead and put the ball links back on. Now, I found it's just easier to disconnect the servos from power.
Yeah.
That way you can move things around as necessary.
Exactly.
I've done that. I've disconnected from power, and I'll just snap my Swashplate balls back on. Ball link connectors on. Okay, and I got to do the tail. Okay, all the ball link connectors are reattached. So the tail is on, and all of the swash, the cyclic and pitch and roll are all on. So what's next?
So this doesn't apply to you, but this is the point where you would level your swash by adjusting the links. But the body has fixed links, so we have to do that in the mixer. This is also where you would adjust the tail push rod to mechanically center it to where they specify in the manual.
Okay. So if you guys are, this is not intended to be a Heli 101 session. Hopefully you know how to level your swash. In my case, what Rob's referring to are that my swash connectors are fixed. They're not adjustable. So we use trim in Rotorflight, and I will show you those fields in a minute. But if you have adjustable swash link connectors, then now is the time to bust out your Swashplate leveling tool, whatever mechanism that works for you, and go ahead and level your Swashplate. The key thing is to make sure in Rotorflight that you've got the servo override turned on. That's the key. And make sure that's on. That's where your swash should be level. And you might have to take your head off or use whatever tools you have to do your leveling, and then get that part done now. We're not going to do leveling here. I've already leveled my Swashplate, so mine is level already. And then regarding the tail, I do want to spend a minute on that, Rob, because you taught me something on this that I didn't know before, and I'd like to make sure that we talk about that for just a minute. So on the tail, the objective is to, let's talk about this. With everything centered, what are we looking for back here?
So it's going to depend on the helicopter, and they usually show you in the manual, but usually you want to get that linkage there from the ball link to the pitch slider. That's usually going to be at a right angle when it's at a center.
Okay, so it looks like mine's actually off a little bit, so I need to probably make an adjustment to make sure that that is perfectly. What we're looking for is this arm to be perpendicular to the boom, right? So we're looking for a straight.
But again, you got to check your manual because sometimes they're something a little different.
Yeah. Okay. All right. So the idea then again is the center. You got to make sure that your rudder control arm is centered on the shaft, right? That's the main thing. But check your manual to make sure you follow whatever instructions they have or geometry back here. And it does look like I need to make an adjustment to mine. Looks like it's off a little bit, but I'm not going to do that tonight. I'll do that later, but that's a little too tedious to do on a video. Okay. All right, Rob. So there we go. What are we into now?
I do want to mention that there is that geometry correction column for those switches up there. Most of the time, a lot of the times with a quality servo like a name brand, KST, MKS or whatever, you can usually turn that on and just use it. But you'll want to look at the tutorial on the Rotorflight website, and it kind of goes over how to actually calibrate that before you use it. And all that's doing is describing to Rotorflight how far the arm moves for a given input to the servo. And it kind of helps, does like geometry correction because you're turning rotational movement into linear movement.
Right.
And that kind of compensates for that. But for the most part, if you don't feel like checking all that, you can just leave it off. It'll be okay.
Okay.
Like we did here. And then with that, we're done with the servos. We can go ahead and turn off servo override, then move on to the mixer.
Okay. So in the mixer tab, go ahead and take her away.
And then here, the first thing we can do is turn on mixer override. And then that way everything's not moving all over the place.
Oh, and I can reconnect my battery.
Oh, yeah.
Okay. So battery's reconnected. Do we want to talk a little bit about the main rotor settings real quick, especially the elevator? Because that's another one that kind of got me initially. Yeah.
Yeah. So, I mean, Swashplate type, but this one obviously is a 120 degree. If it's something else, you'll know that you need to change that. Main rotor rotation, it's pretty much always going to be clockwise. Again, you'll know if that needs to be different.
Mm-hmm.
And then as for the control directions, I was going to show that you could use the override to verify that all works correctly.
Okay.
So you can see in the override, it tells you left, right, backward, forward. So you can override to the right, verify if the swash goes right.
Okay. So let's do that. I'll go ahead and move it right. And we're not going to go crazy with it. We'll just move it a little bit.
Don't go a lot.
Yeah. We're just looking for a little bit here. So that is
like 6 to 9.
Yeah. There it is. That is so when I moved it to the right, the port side of the swash came up and the starboard side of the swash came down. So that is a right turn. That's right.
Correct.
And then we'll do the same thing. We'll check pitch. So we'll do the same thing. We'll set it about 6 degrees, and we're looking for the front to come down, and it did. And let me bring this big camera up. I want to let people see this. So what I'm doing in the configurator is I'm on this pitch slider, and I'm going to bring the pitch slider forward. And when I do that to 6 degrees, that indicates a pitch forward. So the helicopter would actually, nose down and the tail will go up doing that. So that's what we're trying to show here, is that these sliders allow you to verify the movement of the way the gyro understands things to be. And we can do the same thing with collective. So there's a collective slider. When we move the collective slider, we should see the entire collective go up. That's what we're looking for. So, and you can see there it is. I've got a positive collective, and if I come back down to 0, that should move back down, straight down, and it does. So same thing with yaw. Do you want to talk about yaw, Rob? Because I always screw up yaw. There's a trick to it, though.
Yeah, for most helicopters, most 3D helicopters that we're going to be setting up, to bring the tail blades into view, if you give it clockwise and you fold the blade forward, it'll point in the direction the nose is going to go.
All right, let's put the blade. I'm not going to screw the blade in. I'm just going to set it up. And what did you say? Put the blade forward, right?
Yeah, fold it forward.
So it's aimed forward now. And then what?
And then if you override to clockwise,
that
should go to like 20 or something.
Okay.
And that should be clockwise is right yaw, and it's pointing to the right, which means the nose is going to go right.
Okay. So that would be clockwise yaw.
Yeah. Okay. So this is correct.
All right. So this is a good one for you guys to remember, because I can never remember this. I never get this right. I have to look at other helicopters and make sure I have it right. So just to recap, all we did was we took the blade, we set it in the grip. We set it in the grip. There we go. And we took the yaw control, the yaw slider, and we moved it clockwise. Oh, we bent the blade down 90 degrees. So now we move the slider clockwise, and it should point to the right. That's what should happen. It should point to starboard. And when you bring it back to 0, it should be basically in line. So that's the yaw check. And that's a good one to remember, because for me, I can never get that right. All right.
Yep.
So that's it. So I think we're okay on the directions for the servos.
Yep.
So we verified
all the directions are good. And at this point, we're ready to go ahead and put the pitch gauge on, which you already did.
Okay, so I want to show you guys the pitch gauge that I'm using. I got this on HeliDirect. I also have an RC logger, but I'm trying this one out from HeliDirect. And the reason I like it is because it clamps right into the grip. So in the gauge, I don't know if I'm going to be able to get it on camera, but there's the gauge. All right, so we'll talk about what we're seeing here, but there's no really convenient way for me to show you the gauge. without having everything get discombobulated, but we'll explain what's going on. So I've got my gauge attached. I'm going to turn it on, and we're just going to pretend that I zeroed it, okay? If you guys want techniques for zeroing it, what I like to do, and I learned this technique from Fred, is I'll take the gauge and I'll set it on the motor and I'll zero it out. And what I mean by setting it on the motor is I set it on kind of like this, right? Perpendicular to the airframe, and then I zero the gauge out. And then once I've done that, then the gauge is set to reference. So if you look at the gauge, let's see if I can get this in the screen here. If you look at the gauge option right here, you set that to reference, and that'll zero it out. So what that means is that any deviation on the gauge at that point is a deviation from whatever is centered on the motor. Okay? Hopefully that makes sense, but again, this is not Helicopters 101. You should have an idea of how to zero out your gauge and get it into your blade grip. All right. So I just wanted to let you know that we're gonna pretend that I zeroed my gauge out the correct way. Right now it's not exactly zero, but I'm gonna live with it.
Yeah.
We're gonna go
Can't
ahead and do
see
the
it,
demonstration.
so
Yeah.
pretend it's 0.
All right. We're pretending it's 0. So go ahead, Rob. What's next?
All right, so we'll go ahead and have it lined up either over the boom or over the motor like you have it here, so the head is parallel to the boom. And then we'll set the roll to 9 degrees, the override to 9 degrees.
Okay.
And the 9 degrees isn't particularly important. We just kind of settled on that so that we're all calibrating to the same point so we can compare tunes and stuff.
Uh-huh.
And then go ahead and look at your gauge.
I actually see 9.1. I see 9.1 on
wow.
mine. Yeah. Well, don't forget, you guys got to remember, we've already done some work. So there's a little bit of cheating going on because we've already done some tuning. But I'm at 9 degrees. But that's what you're. So if I weren't at 9 degrees, Rob, what would I do?
That's when you go into the cyclic calibration percentage there. Right and here. Adjust that whichever direction you need to go.
Okay. So if I were less than 9 degrees, I would go up, and that will get me up to 9 degrees. So by pressing up, right now I'm at 9.5 degrees. So this is in the cyclic calibration field, and I'm just using the keyboard. So I just click. All you got to do is click in this field right here, and then use your keyboard arrows up and down. And I'm going to bring mine back down to where I had it. Okay, that's exactly 9 degrees right there. That's what I see on the gauge. Okay?
Yep. And so once that's done, you can go ahead and bring that back to 0.
Mm-hmm.
And then now you can go ahead and do the same, but with collective.
Okay. So collective, we'll set it at 9 degrees, and then we're going to look at the gauge. And I see 9.4. So collective calibration, I'm going to bring that down just a little bit. Okay, I see 9 degrees now. So same trick, just click in the collective calibration field, use the down arrow, bring it down or up to get you 9 degrees. And that's what I have now. So now what, Rob?
So now you can go to -9 and then see if it's the same in both directions.
Okay, I see 7.7. So how do I fix that?
So that's going to be the collective geometry correction.
Okay.
If you go negative, it moves both points. It doesn't move the center. It moves your point upper and lower. So as you lower it to fix that, it's going to take away some from the top. So you might have to go back and forth adjusting that and then redoing your collective calibration.
Looks like it maxes out at 25, but again, my gauge is not zeroed out perfectly, so I'm just going to pretend that I hit. We're going to pretend that I hit 9 degrees. Now I'm going to go to the other side. What's that?
Yeah, it was set up before. It's just everything's crooked now.
Yeah,
that's all.
So go back to 9 degrees on the other side and do the same check and make the adjustments. And what you're really trying to do is just zero in on equal values on both sides. That's the main goal. And then if you need to, after you make these adjustments, You might have to go back into your collective calibration and make one more little adjustment to get it back to 9 degrees. So after you get everything kind of centered up and even, then just double check your collective calibration again to make sure that you are seeing 9 degrees. And if not, you can increase or decrease as necessary to get it there. Okay?
Yep.
Okay, so that's how you set your collective pitch to make sure you've got equal pitch up and down. And now what do we do?
All right, so then now you can set your pitch and collective cyclic and collective limits. The default's perfectly safe, which is, I believe, 12 degrees for both or 12.5 for both.
Mm-hmm.
That's another one where you can check the manual, see what the manufacturer recommends is maximum for your helicopter.
Okay.
If you know better, then go ahead and use your preferred numbers.
Yeah. So this is kind of a personal thing, right? That's kind of personal.
Yeah.
Yeah.
If you fly lower head speed, you might want more cyclic and collective than what the manufacturer recommends. Just depends.
Okay.
I do want to point out for the collective blade pitch limit, you want to set that as high as you're ever going to use, maybe even go a degree over just so you have some room, because you actually control that in the rates so that you can have, if you have different rate profiles, you can have different throws. This is setting absolute maximum that you'll ever use at any point.
Right. And the reason this is important is because in order to change this, you need to connect it to a computer. So if you set it to 14, then you can control the upper end in your rates. So you don't have to use a computer. You can do that via Lua on the radio while you're at the field. So that's the pro tip on that one. Okay.
And then the next one's going to be the total blade pitch limit that we went through.
Uh-huh.
Let's see. And for that, we want to use the override to figure that out.
Okay.
We'll set the collective. I find usually going full negative collective, full down is the best way to do it.
And we can go ahead now at this point and use the negative 18 because we've already set a value of the collective blade pitch limit of 14. So it doesn't matter what the slider says, it just won't go past 14. Also make note, I did save my settings. So make sure that you hit save at the bottom before you do this. Okay. So we'll go down.
Save it periodically in case you forget.
Yeah. It's a good idea to save periodically. So I'm going to go all the way down all the way to the bottom. Okay. And now what?
And then we use the pitch. I find pitch is the best way to do it. If you use pitch full forward or full backward in the override, not all helicopters do it, but some of them you'll see the swash ball kind of move up and down slightly as it gets to the extremes.
Right here. So yeah, and this I did actually have this on mine too. So what he's talking about, let me bring the big camera up so you can see. So what he's talking about here is the ball right there. So you keep an eye on that ball. So what happens is when you move that pitch all the way to one direction or another, keep an eye for movement on that ball. All right. So what happens if we see movement?
Yeah, you can go ahead and run that number up a little bit, the total limit. Yeah.
Run it up.
And you see if we can see it.
Yeah, I don't know if you will. It's kind of tricky to see that one, to be honest, but
difficult to see.
Yeah, it's difficult to see.
Right as you get to right at the extremes, you might see the swash kind of actually move up and down,
right,
rather than just tilt. And that's where you can use this adjustment to tune that out.
Right.
And it gives up the cyclic throw to maintain your collective position.
Okay. So the trick there is that we don't want to have when you reach the extent of movement, you don't want to have the Swashplate exceed that and move the ball, because that'll create a little jerk in flight while you're flying.
And some of them are really, really bad about that, and that setting makes a big difference. And of course, you can also lower it even lower than that if you just don't want to load the motor down too much or something like that.
Mm-hmm. Okay. So that's how you calibrate your total blade pitch limit. We've got the pitch all the way back. We've got our collective all the way down. And when we made that movement, we were watching the ball to see. Oh, and by the way, another pro tip: when you're working on this, it can help to use your keyboard to do the driving. So if you put the cursor in the pitch field and then use your keyboard to slide it all the way down, it can be very helpful to spot when that movement happens. So you'll have an understanding there of what to do. Okay. All right. So once we've got our total blade pitch limit set, Then I'll reset these to zeros, and what do we do next?
All right, and then from here, that's pretty much it for the cyclic calibration. You see there's that Swashplate phase angle thing there.
Yeah.
If you don't know what that is, you don't need it, probably.
Okay. Okay.
Basically.
Yep. All right.
And then
let's talk about Swashplate trims.
Yeah, so in this case, you have fixed swash links.
Yep.
So the only way to actually level it is to trim the servos, but in the servos, we don't want the servo arms to be, we want them to be leveled. So you have to do the Swashplate leveling here in this case. Right. It looks like you already went ahead and did all that.
Yep. So I did my Swashplate leveling last night, and I'm happy with that. I measured it very closely, and I'm content that that is level. Okay. Cool. What else?
Let's see. And that's pretty much it for the whole Swashplate. Now we're on to the tail.
Okay. So the head is done. I'm going to go ahead and just remove my pitch gauge. One thing I want, while I do that, I want to mention to you guys, you may have noticed during that whole procedure, I kept putting the swash, the gauge in line with the tail boom and over top of the motor. Make sure you do that. It doesn't do you any good to do all this precision and have your gauge over there while you're taking a reading. It really needs to be in the same spot. So that's why I'm like maniacal about putting it back. You know, I'm constantly putting it back. And of course, every time you make a little change,
roll.
Yeah,
and we're checking roll, so it must be lined up like this to actually measure roll.
Right.
And it was slightly off, and that's probably why we had that big differential earlier.
Yeah, I'm sure it was, and I didn't zero it, so I'll go back to that. But it's mainly the process that we're trying to uncover here. Okay, so that's out of the way now.
So we already covered yaw direction when we were checking all the control directions.
We did, yeah.
So just make sure yaw override is still set to 0.
Yaw override is set to 0.
And then this will help answer a question I saw in the chat too. So when we set up the yaw center in the servos page, it had a little bit of right yaw built into it because that's mechanical center according to the manufacturer.
Mm-hmm.
So we go into here with the override at 0. We can go to the center trim field.
The center trim on the servos?
On the tail rotor settings, the center trim for tail rotor. The last box.
So there it is. I see it.
Got it. Yeah, that one. That's where we tell it what 0 pitch is for the tail. So you'll have to bring the tail back around.
Yeah, let me get the I'm going to get the tail rotor bolts out because we're going to put the blades in because we're going to do that whole calibration.
A lot easier to see that way.
Yeah. So this will take just a minute, guys. I'm going to put the tail blades on real fast. Just take a minute. And we'll show you why this part's important in just a moment. It really is helpful to work out your geometry without getting into slide rules and calculus and origami.
Yeah.
I should have had some Jeopardy music playing for this part. We really did try and think ahead so that we could move through the video at a reasonable pace, not so fast that you couldn't catch what was going on, but we also didn't want it to be like watching paint dry either. So,
well, what you should have done is bought a second helicopter.
A second?
Exactly the same. Oh. That way you could have one with the tail on and then another one with the blades off.
Oh, well, that sounds like a great idea.
Seamlessly switch between them. Yeah.
I'll work on it. All right. There we go. What was funny was when you mentioned something about putting the blades on, I almost had a coronary because I didn't have the blades out. Thankfully, I put them somewhere where I remembered where they were. Hey, by the way, on that note, I just wanted to let you guys know that we did the Radiomaster Nexus Fly Barless giveaway. The winners were announced in Discord, and they all got their email. So I sent an email out. If you entered, make sure you check your email because the winners were sent out. And I'll be announcing their names on the Pilot Jam on Friday. And the reason I'll do it then is because I still have to wait for everyone to give me their information. So until I have all the information, the winner list is not completely final. But so far, 2 of the 3 winners have given me their information. So, okay, looks like I made the whole screen go away. Now it's back. All right. So there we go, Rob. Blades are installed. Now what do we do? We're back in business.
Yeah, back in business. So fold them forward so they're both pointing the same direction.
Okay. So, and we also want them. You want the grips vertical, right? So that's the idea.
Yeah. Or yeah, it doesn't really matter. Just so the blades are parallel. Okay. Whatever way is easier to see.
So there you go.
So in our case, we already did the trim, but if you change that back to 0, you'll see that we'll have a little bit of counter torque pre-applied, which is because that's the mechanical center.
So this is the top blade, in case it's hard to make out on the video. This is the top blade, and it's coming to the right. So why are we changing this back? There's a reason that that's done, and it's anti-torque, right? But why are we changing it back to 0, or from back to over, so that they're completely overlined? Why are we doing that?
It's just so Rotorflight knows what 0 pitch is. That's all we're calibrating here. And yeah, exactly. I think it was at 4.
Okay.
And that gets them parallel. And so now your 0 degree is calibrated.
Okay. So and really, to be honest, again, the camera's not really helping us here, but those are directly over top of each other. So that's a better view.
And you don't need to sweat over 1/4 of a degree. It'll be fine.
Okay. So again, the main point here is Rotorflight needs to know what neutral pitch is. So that's why we're putting that trim in. Okay. Now I'm going to hit save because we've done some stuff. Now what?
Yeah. So we already know that we have 45 degrees of counterclockwise or clockwise blade pitch angle. I don't know if you wanted to show how we figured that out.
Yeah, let's do that for sure. Yeah. Mm-hmm.
Okay. So it's not the way they recommend doing it. It's just the way I've been doing it.
It's a life hack. It's a life hack.
Yeah. So if you pop the ball link off and give it full clockwise throw, we can just kind of guesstimate the blade angle.
Okay.
Ideally, you would measure 30 degrees and calibrate to 30 degrees, just like we did with the Cyclic. But this seems to work good enough.
I got the big camera up and the ball link is popped off. So what do you want me to do now? We're gonna set the full
clockwise. So yeah, the top blade. You can leave them folded. Actually, it's easier to see the angle other way.
Like that.
Tilt or the other opposite angle.
This way?
Like twist them. Yeah, that way. There we go.
Okay.
Trying to figure out how to explain it.
Okay. And then bring the blades down. And what we're looking for there. So I've got full deflection. So let's describe it. The top blade is aiming all the way to the right and it's folded down. The bottom blade is aiming all the way to port and it's folded up. And what we're looking for here is this 90-degree angle, right?
Yeah, and that's 90 degrees, so that tells me that it's got about 45 degrees of clockwise blade angle.
Yep. That's right. And remember, we talked earlier when it goes to the right, the top blade goes to the right, that's clockwise. So that's what he's saying is we've got 45 degrees right there, and we can tell because we see a 90-degree angle right here. So it's not necessarily perfectly scientific, but I mean, I'll put it this way, 45 degrees blade angle on your tail, it's really moving, especially at a high head speed. So
there are some that go up to 60.
Oh, wow.
So that's why you still want to check this and not just assume it's 45. And I think there are some that have considerably less than 45 in that direction as well.
Okay. So bottom line is we feel good that this is 45 degrees.
Yeah, that's good enough.
Okay. So we'll put those back. What if it were less than 45? Then what? We didn't center it correctly, or what's the issue there?
If it's less than 45, then you're going to have to measure it and figure it out and put in the real number.
Okay.
because this is just the mechanical
Oh, that's
possibility.
Right. That's right. That's right.
Yeah.
Okay. And if it's more than 45, same
then
deal.
Also go figure it out.
Yeah.
Or calibrate it to 45 and then hope for the best.
And leave it there.
You can use override set to 45 and then adjust your calibration until it looks like the blades are at 90 degrees.
Okay.
I guess that's another way to do it. But the official recommended way of doing it is to put them at 30 degrees, override to 30 degrees, and measure 30 degrees of pitch.
Okay, that's what we saw in the book, is that whole 30 degrees, and that's
Yeah.
a little challenging on this device. So that's
Yeah.
that's why we did it the way we did it, because you can eyeball it. It's harder to eyeball 30 degrees and get it right. That you can eyeball. You can even use
Exactly.
You can even use like common. I'm just grabbing something off the desk. You could even grab a common device like a coaster and slide it in there and say, yeah, that's pretty darn close to 90 degrees. So, yeah. Okay. So that's it for. So we now know that we have 45 degrees. We feel good about that on the tail. So our clockwise yaw blade angle limit now is set to 45 degrees. Now what?
Yep. So now you can go to override and override it to 45 degrees.
Override. Oh, down here on the bottom.
Yeah.
Okay.
Yeah.
And we're doing clockwise.
Or
We're looking for
clockwise
45. There we go.
Or all the way over, because it's just going to stop at the limit anyways.
Okay. So there's 45. And I'll go ahead and go all the way over. And it stopped. Now what?
And then now you're going to adjust your yaw calibration percent until you hit the endpoint, until the servo binds, and then back it off a little bit.
Okay, so we're looking for this carrier to move all the way to the mechanical extent. And this is why we have a Pro Pilot on, because if you don't set this yaw calibration to 30 before you start, then potentially when you start doing this, you could overdrive the servo, bend your control arm, or who knows what. So that's why we set the yaw calibration to 30 to start, so we don't overdrive. And now what I'm going to do is I've highlighted that calibration field, and I'm going to increase the yaw until I see it come to a full stop and or hear the servo grind. And then I'll back it down just a little bit. Okay, that's all the way to the full stop. I heard the servo grind, and I backed it down just a couple of clicks, and I feel good at 43.1 on the clockwise side. Now what?
Very cool. And then now we can override fully in the other direction. The default counterclockwise limit's going to be a lot lower than it is right now because it's already been done. I think it's like 20 by default.
So I'm going to use, what am I going to do here? This 39.5.
Yeah, so you'd be starting at 20, which would be obviously not enough, and you would increase it till you hit the endpoint and then back it off again.
All right.
Yeah.
So
just like you did.
Yeah. Drive it up. There's the grind. So I'm going to back it down just a couple of clicks. Now I don't hear grinding anymore. That means that's my new blade angle limit for the tail, and I'm going to hit save. Okay.
Yeah. And these numbers don't always match reality perfectly, just depending on if you got the center dead on or not. It's really difficult to get it dead on, so don't stress if it's off a little bit.
Yeah, all that would mean in practical sense is that, turning one direction might be slightly faster than turning in the other, right?
Yeah, and you'll be able to take care of that with the stop gains and all that later.
Yeah. Okay, so I've reset the yaw override back to 0, and I do want to run my check now, right? I'm going to grab my radio. I have to turn off the override. Yeah. And I want to see with control on my radio that I've got that full deflection. And I do see that. So it looks
full
like
deflection, and it's not going too far or anything.
Right. I don't hear grinding.
Which it's not.
Yeah. Okay. That feels good. All right.
Yeah. That's it. Servos are all set up.
That's the tail. So the tail's done. The head's done. And I think that wraps it up, right?
Pretty much.
Okay. Well, there you go, guys. That is the geometry setup on the Rotorflight. Now, I know, a lot of people are talking about Rotorflight being complex, but I'm going to be honest with you. I've done this same exact kind of process on every fly barless I've got. Sure, they look a little different. You know, the buttons may look a little different. The knobs may look a little different. But the procedure, in other words, the steps that we went through in terms of setting the arms at 90, leveling the swash, getting your roll and pitch equalized, those are all, and of course, you know, endpoint set and your tail endpoint set and tail measurements done. That's common on every single fly barless I've ever touched. Looks different, but it's a required procedure to go through. So
yeah, the cyclic calibration, it's the same thing we do with every other system. It's just, you know, you're messing with raw numbers here. That's all.
Yeah. So there we go.
And yes, the yaw is a little bit different, but it's like, you know, there's that one extra step. Otherwise, it was basically the same thing.
Mm-hmm. So after that, you might want to go into your CLI because now you've got your geometry done, and you can type diff all. And once you type diff all, that'll give you your settings, and then you can save that to a file somewhere on your computer, wherever you want. Just save it, and then after that, you can type exit, and your configuration is now saved, and you're ready to move on and continue on with the setup for Rotorflight. Keep in mind, now we're done with the geometry, which was, to me, one of the more critical aspects. Like most of the rest of the stuff on Rotorflight, I can figure out on myself, just on my own with just a little tinkering. This one is kind of important. I think this will probably be the most beneficial video in the whole series because you kind of walk through it step by step and see exactly how to do things without causing any issues with binding, and you know how to get everything set correctly. So, Rob, I can't even tell you how much I appreciate the time you're spending in sharing your knowledge with the community. And I remember when Rotorflight first came out, you jumped in. I was like, God bless him. I'm glad he's doing it.
Yeah.
So
there's a lot of attempts to get to this point.
Yep. So I appreciate it.
A lot better since I started.
Yeah, it is. And having flown it, I already feel really good about flying it. So I already know it's going to fly. Oh, yeah. It'll fly great. So thanks again, man. I appreciate you jumping in and helping share your knowledge on Rotorflight.
Happy to help.
All right. Hey, guys, if you like this kind of content, make sure you subscribe and hit the bell so you know new videos hit the channel. That's all I've got for tonight. Take it easy and go fly something.